Welcome back to Game Development with Pygame. This is part 2 of our platformer. We're going to discuss player movement. In the previous video, we set up the template for our platform game with our game class set up with all of its pieces sort of separated out so we can fill them in with the code we need as we build the different pieces of the game. And so the first thing I'm going to do is I'm going to go over here to settings and I'm going to customize this a little bit to set up for what we need. So I'm just going to name my game Jumpy because I'm going to have a little jumpy character running around. And I'm going to change the window size a little bit because it's kind of on the small side. And I'm just going to make it, I'm going to do 480 by 600. Oops, 600. And I'm going to set the FPS to 60 so we have really smooth movement, right? So that's going to look like this. This is called portrait mode or portrait aspect ratio, which means the height is bigger than the width. If we made the width bigger, then it would be landscape mode. And that would be good for another type of game, but I'm going to do it this way because you're going to see why as we get further along, okay? So now we're ready, and the first thing we want to do is we want to get a player sprite onto the screen. Now I could go in and start adding my my sprite class for the player right here, but remember, keeping with our theme of keeping things organized, we're going to actually make a new file, okay? And we're going to make a new file called sprites.py, okay? And this is going to be sprite classes for the platform game. So in here is where we're going to put our sprite classes, and we're going to import that as well. So over in our main, we're just going to say from sprites import star. Now in the sprite definitions, we may want to use some of the constants that we have in our settings, right? We might add some settings here, and in fact we will add some settings here. So we're also in our sprite classes going to import the settings so that we will have access to those variables. So let's start with our class player. And I'm going to do this, and we better import Pygame or else we won't have the Pygame commands. Import Pygame as PG, right? And so now there's a few different ways we could do the sprite, and especially what I want to talk about in this video is how we're going to do the movement, okay? So there are a lot of different ways you can do movement, and the options are pretty wide. Some of them are going to feel better than others and depend on how you want your game to work. So I'm going to start with really simple movement. So we're going to make a really simple sprite. Let's say 30 by 40, and I'm going to say self.image.fill. I'm going to make him yellow. Did I put yellow in my colors? I did not. All right, so I've got some yellow sprite. We need the rectangle. Okay. Now, one way we could do the movement is just like we did it back in the shmup game, where we had velocity, and the velocity is 0 unless you push the key down, and then the velocity is set to something. So let's just start with that, okay? So we have a Vx and a Vy, right, for the two directions. And our update is just going to say Vx equals 0. I'm going to just stick with X for now and not worry about the up and down movement. And then we're just going to check the key state to see which keys are down. And then we can just see which one it is, right? So left would say Vx equals -5, and PG dot k right would say self.vx equals 5. Moving our sprite, x plus equals vx, and y plus equals vy. Okay, and you can already see how this is kind of nice. Having the player in its own little file keeps you from cluttering up this and having a lot of stuff to scroll through, right? So all we need to do to spawn our sprite now is in our new section, we're going to spawn a player. And we're going to add it to the all sprites group. Oops, and of course I have gone ahead and written Pygame somewhere because we abbreviated that to PG so we wouldn't have to do that. Okay, and I'm making lots of typos today, self.player. It's always easier to type things when you're not talking at the same time. So let's go fix that. Oops, and then we want to run it. Okay, so now we can run, and we have our sprite. Okay, and it can move side to side. It's up there in the corner because we didn't give it a place to start. But you see what I mean by the moving, right? It moves to the right, and the instant I let go of the key, it instantly stops. And that's okay, but it doesn't feel very natural, right? Because when you move, something in the real world moves, it can't instantly stop. There has to be some deceleration, right? There's some slowing down until it gets to a stop. It can decelerate quickly, or it can take a long time, but it still has to do some change. So what we really want to do is add some better movement. Okay, so first let me go ahead and put the player at the center of the screen so that we'll be able to see this better once we start doing it. Okay, and we're going to put this at width over 2, height over 2. Okay. To do the next step and make our movement a little more realistic, we need to talk about acceleration. And acceleration is a measurement of how much your velocity is changing over time. And if my velocity is increasing, then I'm accelerating, so I'm getting faster and faster. And the velocity is really just a measure of how fast your position is changing, right? We already have that. Our Vx is telling it how many pixels to move to the right or left each frame of the animation. So what we want to do now is add into that an acceleration that's going to tell our sprite how fast its velocity is changing. Now to illustrate that, maybe make it a little easier to visualize, I have made this little demo. Okay, so here's our sprite. You can see its position is at the center of my screen, right? And its velocity is 0. It's not moving. Its acceleration is 0, right? Because it's not accelerating. Now, if I press the right arrow key, you're going to see the acceleration change, and then you're going to see an arrow showing its velocity. So see, I'm pressing down, and now I'm moving to the right. I press down, I move to the left. Now you notice when I let go of the acceleration, I keep moving, right? My velocity stays at, in this case, negative 5.6, and I keep moving that way. And if I push it further, I can increase my velocity in that direction. Now, if I want to stop, or if I want to reverse direction, I'm not going to do that instantaneously. When I push it down, you can see my velocity gets slowly back to 0 and then switches to the other direction. So I can accelerate and decelerate, or I can change direction, but I can't change direction instantaneously. And the faster I'm going, the longer it takes me to slow down and change direction. Right? So there's a little bit of floatiness. And we can control lots of things about how quickly and how slowly you can accelerate, and things like that, which we'll be able to adjust. but I just wanted you to see through this little demo, maybe you can understand what we're going to be doing. We're going to have a velocity, that's that green arrow, but we don't control the velocity directly. The arrow keys control the acceleration. And as you can see, the acceleration on this little demo I set to 0.2. Very small number, but you don't need a big number, right? You just need to hold it down longer if you want to go fast. And again, we can adjust that too. Okay, so hopefully that makes a little more sense. And then you'll see how it works when we start adding it into our code. Okay. So how do we go about adding this into our code? Well, this actually won't be too difficult. We're now going to have not just a position, right, which are a location, not just a velocity, but also an acceleration. Now, each one of those is going to has an x and a y component, right? And it's going to get really tedious to have all of these different variables, vx and vy. We'd have to have an ax and an ay, and it's a lot of variables. Well, one thing we can do to keep things a little simpler is to use something called a vector. Now, vectors are kind of an advanced topic in math that you might not have run into yet, but for our purposes here, I'm not going to go into the whole explanation of vectors. I'm just going to tell you that a vector, for our purposes, is just a pair of numbers that have an x and a y component. So instead of our velocity being a vx variable and a vy variable, it'll just be one variable that has an x and a y component, okay? And the way we do vectors in Pygame is there's something called pg.math.vector2, right? 2 for two-dimensional, right? X and Y. But I don't want to type this whole long name out every time I need to use one. So I'm going to basically assign the vector2 command from Pygame to the name vec. So we can just use vec for vector. Okay. So what we would do then is in our player, we're going to change to having a position vector. Okay. That's going to be a vec of width over 2, height over 2, and you'll see why I did this. I'm doing this in a second. We're going to have a velocity vector that's just a vec of 0, 0, and a acceleration vector that's also 0, 0. Okay, so this is the first one is the x, the second one is the y. So to start with, our player is at this position, has this velocity, and has this acceleration. Okay. Now, down here in our update, remember the key press is not going to control the velocity. The key press is going to control the acceleration. Okay, and our acceleration should be 0 unless we're pressing the key. Okay, and if we're pressing the key, then our acceleration.x is going to change. Now remember, in my demo, I used 0.2. I'm going to put 0.5 here for now. Okay, so when we press the left arrow key, we accelerate in the negative direction, which is to the left. And when we press the right arrow key, we accelerate to the right. But now we need to apply that acceleration to say how much does that change the velocity, right? And then how much does that velocity change the position? Okay, so what I'm going to do is I'm going to replace this code here. And I'm going to say so our velocity is equal to, we just add the acceleration. So our velocity, because the acceleration adds to the velocity. And then our position, we add the velocity plus half of the acceleration. Now this comes from, you might recognize this if you've taken any physics. These are essentially the equations of motion, which you'll learn about in physics. You can use to calculate any kind of object moving around in the world. Acceleration might be gravity. That's how you would tell when something's falling. For our purposes, again, we're just going to use these to move our character. I'm not going to go into the details of where these equations come from. You're welcome to go look them up on Wikipedia or any other physics website, Khan Academy, has a really good set of videos on this if you want to see where these equations come from. But you really just need to know the acceleration adds to our velocity, the velocity and acceleration together add to our position, and that tells us where our new position will be. So our new position is now just going to be our, I'm just going to put center. So we just put the center of our sprite at whatever our position is calculated to be. Okay, and that should do this. We just go over here and we run our program. Okay, now I'm accelerating kind of fast, so I'm really zipping off the screen, right? But that's okay. We're going to fix that in a second because I just want to make sure it works. And you can see we're really floaty. We can't sit still, right? This would be fine if we were an outer space game because in space there's nothing to slow you down. But this is going to be a platformer. We're a person running on the ground. So we need to have something that slows us down, right? We don't just keep moving forever. And that thing that slows you down is called friction. That's what we need to control both the slowing down so that if you're not pushing a button, you will coast to a stop. But also, it will help us set our maximum speed so that we can't just keep accelerating and go ridiculously fast. We're almost there. I know the video is starting to get long, but I want to at least add that friction in so we don't have that super high acceleration and we can start coasting to a stop. So here's what I'm going to do. I'm going to make our lives a little easier here, and in our settings, I'm going to add a player properties section. Okay, and so we're going to have in here the player acceleration, right, which we're using 0.5 right now. We're also going to add in the player friction, okay? And the friction is going to actually be a very small number, okay? You'll see this will work just fine. And once we have this working, you can go in and change that and adjust it to work the way you want it to work. I'm using numbers that I've tested before and had them work when I tried them out. So go back over here to player. So now our acceleration is just going to be player.acceleration, okay? So what we called the player acceleration is, oops, I put a dot, I meant an underscore, right? Player acceleration is what we accelerate at. And now before we figure out our new velocity and position, we need to adjust that acceleration by the friction, okay? So our acceleration is actually going to change by our velocity. Basically, the way friction works is the faster you're going, the more friction slows you down. So you multiply by the friction, player friction. Okay, and actually the player friction should be a negative number. Right, it slows us down. I forgot that there. So if we multiply the player friction times the velocity, that'll give us our new acceleration. Okay, and what that will look like now is, see when I let go of the key, see how I stopped? So now I can run to the side and then I stop. I can run to the side and then I stop. If I hold it down, I will keep running, but I also have a maximum speed now. See how I'm not getting above a certain speed? And I can switch directions pretty fast because I'm not going super fast, but it's still not instant. There is a slight pause there, but when I let go, I run to a stop. Now this works pretty well as a guy who is running on the ground, right? You can stop pretty quickly, and we want that. If later on you were to add, an ice level or ice platforms, then you would want the friction to be a smaller number, right? Because then you would coast longer and wouldn't come to a stop. So the last thing I will do now that we have that working is I'm just going to make sure that the player doesn't go off the screen. I'm actually just going to have him wrap around, okay? So I'm going to stick a couple comments here. That applies the friction. These are the equations of motion, right? And then the last thing I'm going to do is after we figure out our new position, I'm going to wrap around the sides of the screen. And we do that by just checking to see if our position is greater than the width, then we set our position to 0. And if our position is less than 0, we set it equal to the width. Okay, and that should do it for this video. We should now have a guy who can run, we can control, has some somewhat realistic motion, and he wraps around the screen so we don't get lost in the nothingness. Okay, so I'll see you in the next video. In the meantime, feel free to go over here and play around with some of these settings. You can see what the friction will change is both the speed at which you stop, so how quickly you come to a stop, but it also will affect your maximum speed. So if you make this number smaller, you can go faster, but you also take longer to stop. And then you can also change this to control how quickly you accelerate, and that's going to adjust things too. So have fun, and I'll see you next time when we start talking about our vertical motion, gravity, jumping, all that fun stuff.